Alright, so good day to everyone and welcome to Moyo Live. Of course, we are preparing for the CSEC exam 2025 and today we are going to prep set theory. So we'll be looking at set theory today. Remember, every Saturday I'll be doing sessions as we lead up towards the CSEC exam in May, June. So share with your friends and share with everyone you know so they can come be a part of the session and benefit in preparation for this very important exam in May, June. So today we're going to look at set theory, and of course with set theory we need to first understand what is a set. So a set is a list or collection of well-defined objects, people, rivers, letters, numbers, you name it, that is a set. And a set is always represented within open and closed curly brackets. And we normally name our set. So if the set is B, it's equal to open curly brackets. We have letters of the vowels of the alphabet, A, E, I, O, U, enclosed within open and closed curly brackets. Of course, with sets we need to understand what is a finite set, what is an infinite set. So this is a finite set. A finite set is a set where we can count the number of elements. So 1 all the way to 10 will be called members or elements. So we have here a finite set because we can count the number of elements. An infinite set is one where we cannot count the number of elements. We have from 1 to 8, yes, but we're seeing some dots going after, which means we're looking at 9, 10, going all the way to infinity. So this here is known as an infinite set. So you have your finite and you have your infinite set. Of course, with set theory, it's important for us to know our set notations. So when we are asked to determine the number of elements of a set. So the number of elements, of course, is represented by common n. And of course, if the set is A, we're stating here the number of elements in set A. And we have how many elements? 1, 2, 3, 4 elements. So if I have a set B, and the elements are, say, 2, 3, 4, 5, 6, and I need to determine the number of elements in set B, I will simply write n, B in brackets, and the number of elements I have here are 1, 2, 3, 4, 5 elements. So we ask the number of elements, we always utilize n, common n. Of course, you put the name of the set in brackets and you count how many elements there are. Alright? So again, with sets, we need to understand the symbols and notations. And we have an element or member of a set. So an element or member of a set is represented by that symbol. So if I have set B, whose elements are A, E, I, O, U, vowels of the alphabet, then clearly A, E, I, O, and U are members of set B. Members of set B. So I know if I have this here, if it's set C, then I know that 2, 3, 4, 5, and 6 are members of set C. Alright, so in short, we know what are members, what are elements, and of course, that symbol will indicate what are the members or elements of the given set. We also have is not an element or member of a set. So this symbol here simply means is not an element or member of a set. So we know set B has elements A, E, I, O, U, but clearly D is not a part of set B, so clearly D is not a member of set B. So we use that symbol to highlight is not a member of or is not an element of a given set. So similarly, if we have this set C, clearly 7, the element 7 or member 7, it is not a member of set C. Alright? So making sure we understand and we can recognize the various notations. We also have our null or empty set. Of course, a null or empty set is a set where there are no members, no elements, and the symbol or the notation we use for the null or empty set will be this symbol, a circle, a line through it, or we can use the two open and closed curly brackets with no elements, no members, so it represents null or empty. So just to show an example of a null or empty set, we have set A, we know pigs with wings. I don't know of a pig with a wing, right? I don't know if you know of pigs with wings, but I don't know of pigs with wings. So clearly that will be null or empty, yeah? So your null or empty set, making sure we are familiar with all the various notation symbols. Universal set, of course, we know it's U, capital U, and universal set is a set from which all elements are taken. Now with the universal set we use U, or sometimes they see a curly E to represent the universal set. So any one of the two can be used to represent the universal set. So make sure we are familiar with the symbols for the universal set. So the universal set is a set from which all elements are taken. So we have our universal set. We have as well subsets. We need to understand subset. So that is a symbol for subset. And what is a subset? Now, one set is a subset of another set when all the elements of one set belong to the other set. So if you look, we have set A, we have set B. Set A has elements 2, 3, 4, and 5. And if you look at set B also has elements 2, 3, 4, and 5. So it clearly shows all the elements of set A are in set B, so we can simply state A is a subset of B. So making sure we can recognize the symbol. So A clearly is a subset of B. All the elements of A are in B. We also have not a subset. So if we look to do the reverse, clearly B is not a subset of A, because all the elements of B are not in A. So we can clearly state here that B is not a subset of A, making sure we can recognize our symbols and we can apply it when necessary. So understanding what is a subset, what is not a subset, and of course the notation, the symbols that are linked to each. So also dealing with subsets, we have the number of subsets. So sometimes I may ask you this in the multiple choice. The number of subsets of a given set. So we know that we have set B whose elements are 1, 2, and 3. And for us to determine the number of elements, number of subsets of a given set, we can use this formula, which is 2 to the power of n. N in that formula represents the number of elements. So n, it simply represents the number of elements in the set. So the number of elements in the set. So we have 3 elements in that set. So we know that n will be represented by or be replaced by 3. And we know 2 to the power of 3 is the same as 2 by 2 by 2. 2 2s are 4, 4 2s are 8. So when we are asked to determine the number of subsets, we can use that formula to help us to determine the number of subsets. We can easily determine the number of subsets. But also, if you want to do it the long way, we can also recognize what are the subsets and count how many to identify the same 8. So automatically, if we have to determine the number of subsets, a null or empty set and the given sets are automatic subsets. So we know that null or empty set is an automatic subset. Other subsets of B, so I'm doing it the long way. Of course, the short way will be to use the formula. Will be 1 is a subset of set B, 2 is a subset of set B, 3 is a subset of set B. And then we look at different combinations. You also have 1, 2 is a subset of B, yeah, of set B. We have 2, 3 is also a subset of B. We have 1, 3 is also a subset of B. All those elements belong to B. So therefore they are subsets of. So we have 1, 2, 3, 4, 5, 6, 7. And of course your last subset will be set B. So when we count, we have how many subsets here? 1, 2, 3, 4, 5, 6, 7, 8 subsets. So automatic subsets will be the empty set, null or empty set, and the given set. Those are automatic subsets. And of course, from this example, we have all the remaining subsets that we can identify. So the number of subsets will be 8. So this is a long approach, but you find most times in the exam, you can use your formula to help you to determine the number of subsets. All right, let's move on to equal sets. What allows two sets to be equal? So equal sets will be sets with the same elements. So if I have a set A and a set B, those two sets are equal. Because if we look clearly, A is a subset of B, all the elements of A are in B, and vice versa. B is a subset of A, all the elements of B are in A. So once that occurs, then clearly A will be equal to B. So equal sets are sets with the same elements. It doesn't matter how the elements or members are arranged, once we have the same elements, then those two sets, in this case two sets, are said to be equal. So equal sets. Of course, sets are not equal if clearly we don't have the same, all of the same elements. Yeah. So in this case, A is a subset of B, but B is not a subset of A. So therefore, we don't have all of the same elements, so therefore those two sets, A is not equal to B, and that's a symbol for not equal to. The equal sign with a line through it, so that is not equal to. Yeah? So we have not equal sets, right? So those are not equal. Equivalent sets. Equivalent sets are sets with the same number of elements. Same number of elements. So in this case, set A, we have 4 elements, and set B, we have 4 elements. So therefore we can state that A is equivalent to B. So they have the same number. So I should write here, N A is equal to N B. And they both will have 4 elements. So therefore we can comfortably state that A is equivalent to B. And that is the symbol we use for equivalent. Sometimes you see the symbol looking like this. So that means A is equivalent to B. So they have the same number of elements. The number of elements in A is equal to the number of elements in B. So you want to make sure we can recognize equivalent. Yeah? Now, moving on to your Venn diagram and complement of a set. So we know that a Venn diagram is a diagram consisting of a rectangle, and you can have a circle, one circle, or circles within that rectangle. Now that circle within your rectangle, well, the rectangle itself will represent the universal set. Remember, the universal set is a set that contains all elements. And the circle within your rectangle, in this case, A is your subset. That circle shows that A is a subset of the universal set. And the complement will simply mean all elements. So A complement is A This is A complement. So we have set A complement is A with that little stroke at the top right. And these are the elements that are not in A. Alright, so if for example, let's place some elements within this Venn diagram. So if I have my universal set, so of course we're going through the set theory, then we'll look at some CSEC past paper questions after to make sure we can apply what we've looked at today to those questions. So if I have my universal set and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my universal set. And suppose I have set A, whose elements are 3, 4, 5, 6, 7, for example, and they ask me to represent that information shown on a Venn diagram, then clearly the universal set will be all elements of the given set. So we expect all elements from 1 to 10 to be placed within that Venn diagram, but the elements are going to be strategically placed. Okay? Within A, we know the elements 3, 4, 5, 6, 7 will be placed within A. But the remaining elements of the universal set, which will be 1, 2, 8, 9, 10. So 1, 2, 8, 9, 10 will be placed anywhere outside of the circle but within your rectangle. So this will be 1, 2, 8, 9, 10. So we have all the elements of the universal set within our Venn diagram, but the elements are strategically placed. So 3, 4, 5, 6, 7 is within A, and 1, 2, 8, 9, and 10 are outside of set A. They are not in A, but within the rectangle, within your universal set. But we need to understand that 1, 2, 8, 9, and 10 will represent the complement. They are not in A, so therefore it's the complement of set A, whose elements are 1, 2, 8, 9, and 10. Alright, so making sure we understand what is complement, what is a subset. So A is a subset of the universal set. All the elements of A are in the universal set. So this is why we show one circle within the rectangle. Of course, you can have more than one circle within your rectangle. So let's look at the intersection of two sets. So the intersection of two sets. So we know what intersection means. Intersection simply means all elements that are common to both sets. So we have A, set A, we have set B, we have this symbol here, which is the intersection symbol. So it's like a N without the little air of the N sticking out. So that is the intersection symbol. And clearly we can see elements common to both A and B. The elements common to A and B are 2, 3, and 4. 2, 3, and 4. So therefore the intersection of A and B will be represented by the elements 2, 3, 4. Straightforward. We also have, by means of a Venn diagram, and very important for us to know. So with intersection, we're seeing here where two circles overlap. So we have intersection where we have elements common to both, but still there are remaining elements in A and remaining elements in B. When that occurs, then we'll show one circle overlap the other, overlapping the other. So in this case, this region here will represent the intersection of A and B elements common to A and B. So you have A and B. This region here, very important, we call that region A only, or in set notation, it's A intersect B complement. So A only is the same as A intersect B complement. This region here it's called B only, or we can denote it as your set notation, B intersect A complement. It's B only. And of course, this region will be all elements that do not belong to the intersection nor the A only, B only. Those that will fall in that region outside of your circles, which will be A complement intersect B complement. So understanding when it comes to a Venn diagram and placing elements, we have to know how to place elements. Alright, so let's take an example. If I have here my universal set, and I have elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me go back to set A and B with intersection. Right? So set A, we have elements 2, 3, 4, 5. Set B, we have elements 1, 2, 3, 4, 5, 6. Okay? And what we want to do is to place that information in this Venn diagram. Now we can do so, and the Venn diagram we're going to draw will be one circle overlapping the other. Reason being, if I look, I have yes elements common to both 2 and 3, as well as 4. But I have remaining elements in A, which will be placed in this region known as A only, and I have remaining elements in B, which will be placed in this region, B only. And of course, remember it's a Venn diagram, so all the elements of the universal set must be placed within that Venn diagram, but the elements are going to be strategically placed. So in my intersection, I know that A intersect B, my elements that are common will be 2, 3, and 4. And I will place 2, 3, and 4 in that region. But of course, the remaining elements of A, which is of course an element in this case of A, will be 5, and that will be placed in A only. So if you look, you have all elements of A. A is the entire circle, 2, 3, 4, and 5. It's there, but the elements are strategically placed. 2, 3, and 4 in the intersection, 5 it is in A only. If you look at set B, the remaining elements of, oh sorry, no. I also have 5. 5 which is also common. So 2, 3, 4, and 5 are common. So let me change this. We make some changes to this question. So I'm going to make some changes. Then realize 5 was also common. Let me make some changes. I have A, whose elements are, let me put 1, 2, 3, 4, 5, 6. I have B, whose elements are 2, 3, 4, 5, 7, 8. Right, so I'm going to make some changes to the question and the 2 subsets. So 2 subsets A and B, and they want us to represent this information given a universal set, elements from 1 to 10. So they want us to represent this information on the Venn diagram. So what do we do? Again, we look for elements that are common to both A and B. Which elements are common? We have 2, 3, 4, 5. Good, so 2, 3, 4, and 5 are common to both A and B. So we know A intersect B, the elements will be 2, 3, 4, and 5. And those elements will be placed in this region here. But then we have remaining elements of A, which are 1 and 6, which will be placed in A only. So if you look, set A will be the entire circle, which comprises of elements in the intersection, elements in A only, but you'll have all the elements of A there. 1, 2, 3, 4, 5, 6. And you also have remaining elements of B, which are what? 7 and 8, which will be placed in B only. So if we look at set B, which is the entire circle, I have all the elements of set B there, but the elements are strategically placed. Some in B only, some in the intersection. So I have 2, 3, 4, 5, and 7, 8. 2, 3, 4, 5, 7, 8. Yes. But remember, it is a Venn diagram, so all the elements of the universal set must be placed within your Venn diagram. Yeah? So we know the remaining elements, which are, we have 1, 2, 3, 4, 5, 6, 7, 8. The remaining elements, 9 and 10, will be placed anywhere outside of your circle. So we have all the elements of the universal set there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the elements are strategically placed. So we know that the elements of A only or A intersect B complement will be 1, 6. We know the elements of B only or B intersect A complement, that will be 7, 8. And we know that the elements of A complement intersect B complement, which are elements that are in neither A nor B, that will be 9 and 10, which is placed anywhere outside of your circle. Right, so ensuring that we can complete the Venn diagram and understand when it comes to intersection that you can see where two circles overlap, and when that occurs, we know that there are elements common to both, but there are remaining elements in A which can be placed in A only, there are remaining elements in B which can be placed in B only, and we proceed to complete our Venn diagram. Okay, so let's look at the union of two sets. So with the union of two sets, we know that that symbol there represents union, so we bring them together, or it simply means elements that are in either A or B or both. So that's what the union means. You have elements in either A, B or both, and when we combine all, this is what we're going to get. We have one without repetition of members or elements. We're going to have 1, 2, 3, 4, 5, and 6. We bring them together. Elements that are in either A or B or both, and that shows the union of your two sets. And the symbol, which is simply a U without the tail. So you can remove the tail. Alright, so that there will be the union symbol. But from the perspective of a Venn diagram, we know that the union simply means elements that are in either A or B or both. So this entire region here represents the union of two sets. So we have A union B, A or B, and of course the region outside of these two circles will be the complement of the union of two sets. So elements that are not in A union B will be placed outside. And of course, that is neither A nor B. So the complement very important for us to know and recognize. So if I have here my universal set, and I have elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I have my set A, whose elements are, I have 1, 2, 3, 4, 5. And I have set B, whose elements are 2, 3, 4, 5, 7, 8. Good? And they asked me, of course, again to place those elements in my Venn diagram. Clearly, we know we have elements common to both: 2, 3, 4, 5. Yeah? We have remaining elements in A, remaining elements in B, so we know our two circles will overlap. So in placing our elements within our given regions, we know that 2, 3, 4, 5 will be placed in that region, which is the intersection. We know the remaining elements of A, which is 1, will be placed in A only. We know that the remaining elements of B, 7 and 8 will be placed in B only. And all the remaining elements of the universal set will be placed outside. So we have 1, 2, 3, 4, 5. So what is missing? 6. We have 7, 8, 9, and 10 is missing. So I'm going to put 6, 9, and 10 right outside of my two circles. But if they ask me now for the union of my two subsets A and B, I'm looking at my elements that are in either A or B or both. So all combined together to give us 1, 2, 3, 4, 5, 7, and 8. So we can go look at A and B and we can bring them together without a repetition of elements. We have 1, 2, 3, 4, 5, 7, 8. But from the perspective of your Venn diagram, you see the elements are strategically placed, but 1, 2, 3, 4, 5, 7, and 8 will be the region. This entire region representing the union. And of course, if we have the complement of the union of A and B, the complement will be those elements that are outside of your circles, which are 6, 9, and 10. So making sure we understand when it comes to the union of two sets, what is meant by union. Alright, so let's look at so intersection and union when it comes to subsets. So we need to understand when one set is a subset of another, then of course we can draw Venn diagrams to represent one set being a subset of the other. So we know A clearly is a subset of B because all the elements of A, 2, 3, 4, and 5, are a part of B, 2, 3, 4, and 5. So A clearly is a subset of B. And four subsets intersection can occur. Clearly we have elements common to both. So 2, 3, 4, and 5, it is common to A and B. You see 2, 3, 4, 5. So 2, 3, 4, 5 will represent the intersection. The union, of course, will be, again, bringing together the elements of both subsets. So we're going to have, without repetition, 1, 2, 3, 4, 5, and 6. So we know that's intersection, that's union. But from the perspective of a Venn diagram, and this is where we have to be careful. So when it comes to the intersection and union, from the perspective of a Venn diagram, you're going to show one circle within another circle. So when you show one circle overlap the other, it's one circle within the other circle. And this occurs when we have one set being a subset of the other. Okay? So we draw one circle inside the other. And this here, the intersection is represented by A, and the union is represented by B. And I'll show by means of an example. Yeah, so if we have here, if I have my universal set, and my universal set I have elements, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have my set A, whose elements are, say I have 3, 4, 5, 6, 7, 8. And I have a set B, whose elements are, say we have 4, 5, 6, 7. Okay? And they ask us to draw a Venn diagram to represent the information given. Now, if we look, yes, in drawing your Venn diagram, we look to see if there are elements common. Clearly, we have elements common to A and B. 4, 5, 6, 7. Those are the elements common to A and B. But if you look, all the elements of, let me switch it around. Let me put this as A here. Let me put that as B. Right, so I'll switch around the names. So all the elements of A are in B. All the elements of A are in B. So because all the elements of A are in B, then we know that that region in purple, this region here, will represent the intersection. And of course, we will show one circle drawn within another because all the elements of A and B, A is a subset of B. We can show one circle drawn within another, but this region here will represent the intersection because we have elements common to both 4, 5, 6, and 7, which will be placed here. Alright? So those are the elements common to both. And because A is a subset of B, you show one circle inside the other, but the elements common to both will be placed in A. The remaining elements of B, 3 and 8, will be placed in this region here, which is known as B only. So that is your B only. So that is B only. And of course, all the elements of the universal set must be placed in your Venn diagram. So therefore, the remaining elements we have 3, 4, 5, 6, 7, 8. So the remaining elements which are 1, 2, we have 3, 4, 5, 6, 7, 8, right, 9 and 10 will be placed outside. Good? So of course we can place the same here and we'll identify intersection and union. So I'll place the same elements here, 4, 5, 6, 7. I'll place 3 and 8 here. And of course 1, 2, 9 and 10. So if we have to state now the elements of A intersect B, the elements of A intersect B is the same as set A. Good? That's the intersection because we didn't one set being a subset of the other, one circle inside of the other. So this region here represents the intersection. 4, 5, 6, 7, which is set E. If we're looking at A union B, A union B, looking at this diagram here, A union B, looking at set B. union will be this entire region here, which is set B. And that will be equal to the elements 3, 4, 5, 6, 7, 8. So I'm going to place 3, 4, 5, 6, 7, 8. So when it comes to one set being a subset of the other, we show one circle within the other circle, one circle inside of another. Of course, we strategically place our elements, but for the intersection, it's going to be set A, and the union is the entire region here, which represents set B. Of course, this region where we have 3 and 8 located, that is the same as B only, which we can write as B intersect A complement. This is B only, whose elements are 3 and 8. And the region outside represents, remember this entire region represents the union. So everything outside of that region will be a complement, or we denote it as B complement. So it's a complement of A union B, or B complement. So this region outside of your circle, remember this entire circle is B, so outside of course will be B complement or A union B complement. So A union B complement or B complement will comprise of the elements 2, 9, and 10. Alright, so we want to make sure that we are clear on placing our elements, making sure we are clear on your Venn diagrams. Alright, it's not always one circle overlap the other. You can have one circle drawn within the other, and that is done when one set is a subset of the other. Alright? Okay, so let's move on to disjoint sets. So another way we can represent our subset within our universal set, so your circles within your rectangle, will be 2 circles that are not overlapping, or 2 circles where one is not within the other. You can have 2 separate circles, which is known as disjoint sets. So 2 separate with disjoint. And for disjoint sets, intersection and union occur. But for disjoint sets, note the intersection. We have no elements common to A and B. You have A, you have B. Once those 2 circles do not overlap, or you do not see one circle inside of the other, 2 circles are separated, then clearly the intersection will imply that they are empty. The union, of course, will be to take both A and B and we bring them together to give us 2, 3, 4, 5, 6, 7, 8, 9. So we combine them together. So in terms of a Venn diagram, we have here set A and set B, and you see where both are separated, disjoint within your rectangle. But this also represents A union B, A or B, and the region outside represents the complement of A union B, neither A nor B. So if we have, we can go back to the same elements I had previously, which I'll place inside here. If I have, let me put a universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have my set. A, whose elements are 2, 3, 4, 5. I have set B, whose elements are 6, 7, 8, 9. And we have to place those elements in this Venn diagram, and it's going to be that Venn diagram because if we look, we have no elements common to both A and B. So the intersection there, it is what? Null or empty. So clearly, it will imply that those 2 subsets are disjoint, separated. So what we're going to do is to place the elements of A, 2, 3, 4, and 5 within set A, the elements of B, 6, 7, 8, 9 within set B, and of course the remaining elements of the universal set. We have 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 10 is missing. So 1 and 10 can be placed anywhere outside. So we have all the elements of the universal set there, but strategically placed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah? So we know if they ask us for A intersect B, that clearly is the empty set. So no elements common to both. If they ask us for A union B, we're going to take the elements of A and B, we combine them together to give us 2, 3, 4, 5, 6, 7, 8, 9. And if they ask us for the complement of A union B, then we know that's neither A nor B. The complement will be the elements 1 and 10. Right, so making sure we can recognize the three ways in which we can place our elements within a Venn diagram. Two circles overlap, one circle inside of another, or two separate circles. Right, we're dealing with two sets. Okay, so let us look at some past paper questions now in relation to our set theory. So they ask us to describe using set notation only the shaded regions in each Venn diagram below. The first one is done for you. So this is clearly intersection. So they want us to using set notation to describe the shaded region. So A intersect B is first. The set, well, they give us as an example, but part 1, this clearly is what? The union. So you see that that's the union of A and B. A and B are the two subsets given, and that is the union representing that shaded region. 2, this region here, remember we have this joint set which also represents union, but the region outside will be the what? Complement of A union B. So for part 2, this will be the complement of A union B. So you see that because they ask you that in the multiple choice, sometimes they bring it in the structured paper. And of course the last 3, the entire circle A, it is shaded. So that there represents A. So ensuring that we are clear, we can recognize when we have the shaded region, what the shaded region signifies, what it represents, the set notation, and ensuring that we are clear. So let's look at part B. The following information is given. You have the universal set from 1 to 10. You have prime numbers. Remember last week we looked at number theory. So you have your prime numbers, you have odd numbers, even numbers, composite numbers, and so on. Right? Go back, look at the video that I have in the YouTube channel. I'm going to see number theory part 1 and 2. And we have to, in this case, draw a Venn diagram to represent the information above. So you want to draw a Venn diagram. So let's draw a Venn diagram. So looking at some CSEC past paper questions here. So we have here our universal set, we have elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have P, which are prime numbers. And let's see if you remember what are prime numbers. Prime numbers are numbers that can only be divided by itself and 1. And prime numbers starts from 2. So let's identify all the prime numbers in that universal set. So your prime numbers here will be 2. 2 can be divided by itself on 1. 3. 3 can be divided by itself on 1. 5 can be divided by itself on 1. 7 can be divided by itself on 1. Right? So those are your prime numbers. Q. Your odd numbers. Odd numbers are numbers that cannot be exactly divisible by 2. So your odd numbers here will be 1, 3, that's what the universal set, cannot be exactly divisible by 2, 5, 7, and 9. So making sure we know our prime numbers, we know our odd numbers, even numbers, and so on. So they want us to draw a Venn diagram to represent this information. So we know in drawing our Venn diagram, there are 3 Venn diagrams we encountered previously while doing our review. And let's see. If we look at our 2 subsets P and Q, we have elements common to both. 3, 5, 7. And of course, we have remaining elements in P, remaining elements in Q, so we know when we are drawing our Venn diagram, it's going to be one circle overlapping the other. So we're going to have here my rectangle representing my universal set. And I'm going to show one circle overlap the other. So this is P, and that is Q. And now I want to place my elements. So I know that 3, 5, and 7 will be placed in the intersection. 3, 5, and 7. The remaining elements of P, which is 2, will be placed in P only. The remaining elements of Q, which are 1 and 9, will be placed in Q only. And remember, it's a Venn diagram, so all the elements of the universal set must be placed within that rectangle. So therefore, the remaining elements, and again, all strategically placed, the remaining elements, we have 1, 2, 3, so 4 is missing. We have 5, 6 is missing. We have 7, we have 9, so we have 9, so 7, 8, and 10 are missing. So 7, 6, sorry, no, 7 is there. Right, so 8 and 10 are missing. So we have 1, 2, 3, right, so 4 is missing, so 4 will be placed outside. We have 5, 6 is missing, 6 will be placed outside. We have 7, 8 is missing, 8 will be placed outside. 9 is there, and 10 is missing, 10 is placed outside. So that there is our Venn diagram representing the data, the information given. Alright, so we want to ensure that we are clear on drawing our Venn diagrams. So let's look at another example. So looking at some system past paper questions here. So let me erase. So before I do this question, let me quickly change my marker. So, T and E are subsets of the universal set U, such that we have the universal set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's our universal set. T equals multiples of 3. So we did multiples when we looked at number theory last week. So T multiples of 3. What are multiples of 3? Think of your 3 times tables. So 3 by 1 is 3. 3 by 2 is 6. 3 by 3 is 9. 3 4s are 12. So think of your tables. So multiples of 3 from that universal set will be 3, 6, 9, and 12. Those are multiples of 3. Even numbers, so E representing even numbers. Even numbers, of course, will be numbers that are exactly divisible by 2. So let's identify all even numbers from our universal set. That will be what? 2, 4, 6, 8, 10, 12. So you have all your even numbers there based on the universal set. So they want us to draw a Venn diagram to represent the information. So let's draw a Venn diagram. We know that our Venn diagram, there are 3 we can think of overlapping, one circle inside the other separated. So let's see what this will apply to the information. So we have here elements common to both. Do we have elements common to both? Yes, 6. We have 12. So we have elements common to both. We have remaining elements in T, remaining elements in E. So therefore we know that our 2 subsets will overlap. So we'll have our rectangle representing your universal set. You will have set T. You have set E. They both overlap, and the elements that are common to both will be placed in this region here, which will be 6 and 12, representing the intersection of T and E. Of course, this region here represents T only, so the remaining elements of T, which are 3 and 9, will be placed in this region. And the remaining elements of E, which are 2, 4, 8, and 10, will be placed in this region. Of course, it is a Venn diagram, so all the elements of the universal set must be placed in your Venn diagram. The elements are strategically placed. So the remaining elements are, so we have, alright, 1 is missing, 2, 3 is there, 4, 5 is missing, 6 is there, 7 is missing, 8 is there, 9 is there, 10 is there, 11 is missing, and 12 is there. So let's make sure we have all the elements of the universal set placed in our Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, but the elements are strategically placed. And then they ask us in part A, list the elements of T, and remember this symbol means intersection. So they want us to list the members of the set T intersect E, which will be elements 6 and 12. We have part B. List the elements of the complement of T union E, the complement of T union E. So T union E will be this entire region here. This is T union E. That's T union E. So the complement will be those elements that are not in T union E, which will be elements outside, and that will be 1, 5, 7, and 11. So making sure you know we're clear, easy questions. You see that in your CSEC exam, and again, also you'll see sets in the multiple choice. Ensure that we can answer these questions comfortably. Alright, let's look at another question. So we're looking at some possible questions here, making sure we're comfortable with our set theory. Remember to like, share, and subscribe to Moyo. Share with your friends. Let them come be a part of the sessions every Saturday from now until the exam in May, June. Okay? So a universal set U is defined by, so we have a universal set U defined by the elements 51, 52, 53, 54, 55, 56, 57, 58, 59. And A and B are subsets of the universal set, so subsets A and B. A, we have odd numbers. We know odd numbers are numbers that cannot be exactly divisible by 2. So our odd numbers here will be, based on the universal set, cannot be exactly divisible by 2. We have 51, we have 53, we have 55, we have 57, we have 59. So those numbers cannot be exactly divisible by 2. Oh, sorry, no, not 51, because 51, 3 can, sorry, that's 2 yes. Exactly divisible by 2 yes, so 51 is there. So we have B, prime numbers, right? So prime numbers are numbers that can only be divided by itself and 1, yeah? By itself and 1. So our prime numbers here will be what? I'm looking at the universal set. Our prime numbers here will be 53, yeah? Can only be divided by itself and 1. Let's see what else. And 59. Good? Those are our prime numbers. So if we are to draw a Venn diagram to represent the information, yeah? We know, let's double check here, odd numbers 51, can be exactly divisible by 253, we have 55, we have 57 and 59, and our prime numbers will be 53 and 59. Good, yes. So, what we want to do is to draw a Venn diagram to make sure, now clearly we have elements common to both. But if we look, for us to draw Venn diagrams, you were exposed to 3 Venn diagrams. In this case, we are not going to show one circle overlap the other. No, because if we look, all the elements of B are in A. All. So it means that B is a subset of A. So when you're drawing your Venn diagram, you're going to draw a rectangle representing your universal set, and you're going to have one circle drawn within another. Of course, this circle will be B, and this will be A, And what we want to do is to place our elements. So the elements common to both, which is 53 and 59, will be placed in that region. The remaining elements of A, which are 51, 55, and 57, that will be placed in A only. And of course, it is a Venn diagram. All the elements of the universal set must be represented. So we have here the remaining elements of the universal set. So we have 53, we have 51, 52 is not there, so 52 will be placed outside. 53 is there, 54 is not there, placed outside. 55 is there. 56 is not there, placed outside. 57 is there, 58 is not there, placed outside. And we have 59 there, alright? So all the elements of the universal set are there, 51, 52, 53, 54, 55, 56, 57, 58, 59, yes? So we have our completed Venn diagram, but one circle drawn within the other. So when they ask us to list the members of set A, which we did, list the members of set B, which we did, draw a Venn diagram to represent sets A, B, and U, but that is it there. Alright? So let's look at another. Right, so we want to make sure we're clear on as well the number of elements in two sets. So we looked at elements in two sets. What about the number of elements? Number. So let me erase. So the number of elements in two sets. So remember when we talk about number, we have n. Alright? So we have here the number of elements in P is 30. Number of elements in Q is 24. Number of elements in P intersect Q is 9. And they want us to, of course, just to complete that Venn diagram, evaluate A, number of elements in P intersect Q complement. What P intersect Q complement represents, that represents P only, which is this region here. Okay? So if, and of course they also state right, and if they want us also find, that would be one time, number of elements in Q intersect P complement, which is Q only. So, in order for us to find the number of elements in P intersect Q complement, which is P only, this region here, we know that the number of elements in P is what? 30. That's the entire circle. Yeah? But 9 is a part of it. 9 is a part of that circle. So for us to determine the number of elements in P only, all I'm going to do is just simply subtract 9 from 30. So this is 30, subtract 9, which will give me 21. So that's the number of elements in P intersect Q complement, which is also P only. Yeah? So this region here is P intersect Q complement. And we want the number of elements in that region, so we form that to be what? 21. And we have what? The number of elements, part B, in Q intersect P complement. That is Q only, which is this region here. Right? That's Q intersect P complement. Q only. So for us to find the number of elements, what we have to do, obviously, Q is the entire circle, so the number of elements in Q will be 24, and we know 9 is a part of it, 9 representing your intersection. So to determine the number of elements in Q only, I have to subtract 9 from 24. Which will give me 15. Yeah? So the number of elements in Q intersect P complement or Q only, it is 15. Alright, so making sure we understand when we talk about number of elements, how it is calculated. Alright, number of elements. So remember, when we see 30 is not an element, 30 is not an element, it's a number of elements, okay? So let's look at another example. This time if we have X representing the intersection of P and Q. So we have here the number of elements in this universal set is 50. We have the number of elements in P is 27. Number of elements in set Q is 31. The number of elements in P union Q, or the complement of P union Q, that's 4. And the number of elements in P intersect Q, X. So the number of elements in P intersect Q is X, which you already have. So the number of elements in P, it's 27. The number of elements in P, that's 27, which is the entire circle. The number of elements in Q, it is 31, which is also the entire circle. The number of elements in the complement of P in P union Q. Remember, P union Q is the entire region here. And you have the complement of P union Q, which are elements that are not in the union of P and Q. So that is 4, that is outside. And the number of elements in P intersect Q will be X, so X at the middle, which you already have. Good? So they want us to first evaluate X. How are we going to find X? And remember the number of elements in the universal set, it is 50. Now how are we going to evaluate X? Now in mathematics, remember, to solve for any unknown quantity, you must create an equation. Very important. So we want to find X first. So in order for us to find X, we have to create an equation. So how are we going to create an equation from this? Now, let's think of students. So you have 50 students in a class. Let's consider that 50 to be students in a class. So if I have 50 students in that class, and suppose I have students in that class who play the piano, and I have students in the class who play the quattro. Yeah, the quattro, right? And we want to determine what is X. We need to create an equation. So your 50 students in your class will comprise of students who play the piano only. So you have a group of students in the class of 50 who play the piano only, which is formed by doing what? This region here is formed by subtracting X from 27. So piano only, you have to fill this region. 27 is the entire circle. X is a part of it. X is representing the intersection. X is a part of P. So to find this region, I have to subtract X from 27. So this region is 27 minus X. So we have the number of students who play the piano only. But then we have students in the class who play both, which we have as X. And we have students in the class who play the quattro only. So the quattro only, which is this region here, can be found by subtracting X from Q, which is Q subtract X. right? Or 31 subtract x. Q being represented by, or 31 represents Q. Yeah? So therefore, for us to find the number of students who play the quattro only, of course we subtract x from 31, and those in the class who don't play any of those instruments, the piano nor the quattro, we have 4 of them. So that's a class of 50. Those who play the piano only, a group of students. Those who play both the piano and the quattro, a group of students. Those who play the quattro only, a group of students. And those who don't play any at all, that's a class of 50. So if we have to evaluate x, we must create an equation. This is our equation. The equation is this, part A. 50 is equal to a class of 50. Those who play the piano only, plus those who play both the piano and the quattro, plus those who play the quattro only, plus those who don't play any of the instruments. That's a class of 50. Alright? And what we want to do is to solve that equation so we can find x. So let's solve the equation. We know negative x plus x, that's 0. 27 plus 31, that is 58. And 58 plus 4, that will give us 62. So we'll have here 62. Subtract x. Negative x plus x is 0. 27 plus 31 is 58. 58 plus 4 will give us 62. And of course, we have negative x remaining. Of course, 50 is equal to 62 subtract x. It's a simple equation now. So I'm going to place x over negative x from the right to the left. So it comes across to the left as positive x. So I add x to both sides. And I'm going to remove 50 from the left to the right. So it's going to be 62. And positive 50 comes across to the right as negative 50. Well, I can subtract 50 from both sides. And therefore x is equal to 62 subtract 50 will be 12. So we consider x to be students who play some instrument, let's assume. Then the number of students who play both the piano and the quattro, if we consider P and Q to be piano and Q quattro, those instruments, then the number of students will be 12. That's x. So let's look at part B. Part B, we want the number of students who play the piano only. Right? The number of students who play the piano only. So for us to determine the number of students who play the piano only, which is this here, 27 subtract x, because I know x is equal to 12, I just calculated x as 12, then I can determine the number of students who play the piano only, which is 27 subtract 12. And that will give me 15 students. And we have C, number of students who play the quattro only. The quattro only is here, 31 subtract x, and I know x is equal to what? 12. So all I have to do is to subtract 12 from 31. Yeah? And that will give me 19. So 19 students play, if you consider Q to be quattro only. So Q intersect P complement is the same as Q only, which is at 31 minus x. P intersect Q complement is P only, that's 27 minus x. Of course, we got x as 12, which will help us to find B and C complement. Alright? Alright, so let's look at another. Right? Okay, so let's look at this one here. Right. In a survey of 30 families, the findings was that 15 families own dogs, 12 families own cats, X families own both dogs and cats, 8 families own neither dogs nor cats. Right? U representing families, that's a universal set in the survey. C, families who own cats. D, families who own dogs. And they gave us that Venn diagram and they want us to copy and complete it. So simple. Cats, dogs, right? So we have here 30 families, so which will be the number of elements in the universal set, that will be what? 30. Right? So number of families who own dogs, that's 15, which is the entire circle. So students make a mistake and they place 15 here. This is dogs only. So the number of families who own dogs will be 15. The number of families who own cats, it's 12. So please don't put 12 here. That's cats only. So the number of families who own cats, it's 12. The number of families who own both dogs and cats, you know that's intersection. That's X. Number of families who own both dogs and cats, that is X. And the number of families who own neither dogs nor cats. So neither dogs nor cats. Right? That is the complement of C union D, which is object region. So C union D outside represents a complement, and that is what? 8. So they want us to what? 1. So that is, so we need to complete the Venn diagram shown below. So clearly, if the number of persons or families who own cats, I'll start here, is 12, then the number of families who own cats only will be to subtract X from 12. The number of families who own dogs will be 15, so the number of families who own dogs only will be 15 subtract X. And the number of families who don't own any of those animals, dogs nor cats, it will go outside. Right, so making sure we can complete our Venn diagram. And they ask us, so this is part 1. So looking at some CSEC past paper questions. Part 2, write an expression in X which represents the total number of families in the survey. An expression, not an equation. An expression, of course, will comprise of terms, and those terms can be separated by addition or subtraction signs, right? So we have here, let's look at our expression. Our families, we have all the families in the survey, 30 families. The 30 families comprise of those who own cats only, plus those who own both dogs and cats, plus those who own dogs only, plus those who don't own any. So the 30 families they would have surveyed, note 12 minus X will represent those who own cats only. So you have some families who own cats only. You have X will be families who own both dogs and cats. You have 15 minus X, so you have some who own dogs only. And you have and those families that don't any. So this here is your expression. There's no equal sign there, and all I'm going to do now is simplify. So you can simplify your expression. You can leave it like that, but you can simplify the expression as well. So I'm going to say 12 plus 15 is 27, and 27 plus 8 will give me 35. Negative x plus x is 0, and I'm left with negative x, so I'm going to get 35 minus x as my expression for the total number of families in this survey. And now they ask us now, write an equation which may be used to solve x. So to write an equation involves an equal sign. And look how easy we're going to create our equation. We have 30 families in this survey, and this is the expression also representing the total number of families. Total number of families in the survey 30, and as an expression, the total number of families is 35 minus x, which means they are the same. We can equate them, we can place them equal to each other. So this is 35 minus x is equal to 30. If you write it as 30 minus 35 minus, it doesn't matter which goes on the left, which goes on the right. And now we can solve for x. So I will take negative x, I'll bring it over. And I'll take positive 30, bring it over. So negative x will come across to the right as positive x. And positive 30 will come across to the left as negative 30. X will be equal to 5. So you have solved for x, which represents families who own both dogs and cats. So making sure that we understand set theory and the number of elements and where equations can come into play to help us. Alright? So we look at about just 2 more questions. Yeah? So we have here now right, so making sure we get that practice, making sure we are clear on how to treat with such. So the Venn diagram below shows the number of students who study music and art in a class of 35 students. So you have the universal set represents students in the class, M equals students who study music, A students who study art. And what we want to do is determine how many students study neither art nor music. So this is pretty straightforward. So the number of students who study neither art nor music So the number of students who study neither, and I'm going to write it in terms of a set notation so you can get familiar. So neither art nor music will be, number of students who study neither art nor music will be A representing art, union M representing music, and we have the complement, because remember this entire region represents students who study art and music. You have that union representing 2, with either art or music or both. Good, representing the union. And of course, those who don't study either of the 2 will be placed outside. So neither art nor music will be 4. So I've been written in the set notation. And what I want us to do now is to calculate the value of x. So to calculate x, we're going to create an equation to help us to find the value of x. So let's create an equation. So anytime we're asking math to find an unknown quantity, we must create an equation. So we know that in this Venn diagram below, it shows the number of students who study music and art in a class of 35 students. So you know that the number of students in the class will be 35, which is a universal set. So 35 students will comprise of those who study music only. That's a class of 35, plus those who study both music and art. So you have students who study music only, some of them. You have students who study both music and art, some of them, which is 8. You have students who study art only, which is X. You have students who do not study any of those subjects, which is 4. So you have your class of 35. You have created an equation. And what we can do is obviously solve the equations. You can comfortably find X, testing your knowledge of solving equations. And this will be what? 35 is equal to X plus X, which will give us 2X. This is 5 plus 8, which is 13. 13 plus 4 will give us 17. I'm going to subtract 17 from both sides. I will bring 17 over to the left. So this will become 35 subtract 17 is equal to 2X. When I subtract 17 from 35, that will give me 18. It's equal to 2X. And what I can do now is to find X by dividing both sides by 2. X is equal to 9. And part 3, they ask us to hence state the number of students who study music only. So music only will be this region here. X plus 5, we found X to be 9. Yeah? So the number of students who study music only, and I write it as a set notation. So music only in set notation will be M, number of students, M intersect A complement. So get familiar with the set notation, that's music only. So if you got X as 9, then you're going to add 9 to 5, which will give you 14. So the number of students who study music only will be 14 students. Alright, so we're going to these past paper questions, making sure we clear how to answer these set questions. Remember, every Saturday from now until exams, I'll be doing sessions, revision sessions on all topics. We started with number theory last week, now we're into set theory, and we're going to continue pushing forward, and we bring all the topics that we need to know in preparation for the exam, right? Even though it's set theory, you see more so in multiple choice, and make sure you understand so you can answer it comfortably, right? So we'll look at one more. So a survey was conducted among 40 tourists. The results were 28 visited Antigua, 30 visited Barbados, 3X visited both Antigua and Barbados, X visited neither Antigua nor Barbados. Copy and complete the Venn diagram below to represent the given information. So they want us to complete this Venn diagram straightforward. So we know that there are 40, a survey was conducted among 40 tourists. So the number of tourists will be 40, which represents a universal set. 28 visited Antigua. So the number of tourists who visited Antigua, that's what, 28. And we know that's the entire circle. Please don't place 28 here. That's 28 only, right? So the number of tourists who visited Antigua, that's 28. Yeah? And then they ask us, of course, they told us as well, 30 visited, the number of tourists who visited Barbados will be 30. So we know 30 is the entire circle. Please don't place 30 here, that's Barbados only. So the number who visited Barbados will be 30. 3x visited both Antigua and Barbados, which is the intersection. So the number who visited both Antigua and Barbados, which is the intersection, 3x I will place in this region. And the number who visited neither Antigua nor Barbados will be x, that goes outside. And of course, it's important to know the set notation. That is the number of A union B complement, that's x. That's neither. So remember, this entire region represents a union. So outside, of course, will be the complement of that, right? So they want us a copy and complete, so easy completion. This region needs a fill, which is A only, Antigua only. This region needs a fill, which is B only, Barbados only. That can be easily found by subtracting 3x from 28. Simple. And this region can be easily found by subtracting 3x from 30. So we have filled all the regions that are of importance to us. So we have completed the Venn diagram, and then they ask us to write an expression in x to represent the total number of tourists in the survey. A simple expression. So you know part 2 is to recognize that your 40 tourists will comprise of those who visited Antigua only, plus those who visited both Antigua and Barbados, plus those who visited Barbados only, plus those who did not visit any of the islands, of the 2 islands. So that is your expression, no equal sign. That's your expression, which you can simplify. So you're testing your knowledge of simplification. This is 28 plus 30. That will give us 58. Negative 3x plus x will give us negative 2x. Negative 2x subtract 3x will give us negative 5x. Negative 5x plus x will give us negative 4x. So that there is your expression in terms of x. And then they ask us to calculate x, which means you have to create an equation to calculate x. Our equation is simply, if you have 40 tourists who were in this survey, 40 tourists, of course, represented as an expression in terms of x. It's 58 subtract 4x, so they are both the same, and we can equate them by putting 40 equal to 58 subtract 4x, or 58 subtract 4x is equal to 40. It doesn't matter which goes on the left, which goes on the right. And let's solve our equation. So negative 4x, I will move from the right to the left as positive 4x, and I'll place positive 40, move it from the left to the right. 58 subtract 40. So what are we going to get? This will be 4x is equal to 18 and therefore 28 subtract 3x, 30 subtract 3x, 28 subtract 3x. Oh, sorry, mistake. So those who visited Antigua and Barbados only, that would be 3x. Yeah? Not x, 3x. So I'll recalculate the expression in terms of x and the total number of tourists in the survey. So this is 3x here, not x. So that will be 28 plus 30 is 58. So 3x, negative 3x plus 3x is 0. And negative 3x plus 2x will be, plus x, sorry, will give us negative 2x. So we're going to get 40 is equal to 58, subtract 2x. And I'm going to bring negative 2x over to the left as positive 2x. Of course, 40 over to the right as negative 40. I'm going to get 58 subtract 40, which is 18. Of course, this will be 2x. And therefore, I can solve for x by dividing both sides by 2. X will be 9. Okay? So when I replace x with 9, 9 by 3 will give me 27. It means 27 tourists visited both Antigua and Barbados. If we were asked to determine the number of tourists who visited both islands, we just simply replace x with 9 in this case, and 9 by 3 will give us 27. Okay? Yeah? Alright, so this will bring us to the end of the exercise today. Remember, next week, every Saturday from now until exams, I'll be reviewing every single topic that we need to know in preparation for our CSEC examination. So please tell your friends, make sure you benefit from the sessions. Of course, the videos will be uploaded to YouTube, so you can look at the videos as well and ensure that you benefit from what was taught. But more so importantly, spread the word and get everyone on board to benefit from these sessions every Saturday. Alright, so with that said, have a great evening. Take care, everyone.